In this episode, we're going to explore application use cases for authority access using a QA server. To do this, we'll look at 3 use cases from several orientations, including authority-oriented, expanding context-oriented, and entity-oriented. The first use case is authority-oriented. It has the goal to use an external authority to find and retrieve a single value. That value may be used as an authority term or as a controlled vocabulary term. Ultimately, our goal is to get the URI associated with the term. We may also choose to cache the terms labeled to be able to do things like search for that term within our application and display the term's label without having to make an external call to get it. In this example, we have the keywords field. We want to select a term to use for this field. The basic workflow is that we make an API call to the QA server indicating that we want to do a search. We pass a query string and the QA server will pass back multiple potential terms. We may also get back additional context for each term that can be displayed to the user to aid them in the selection process. Providing additional context to the user can increase their confidence in the selection. Once the user selects a term, the URI is saved as the value of the field and the label can be cached. We see here the API call that provides the autocomplete functionality for the keywords field. The API call goes to a QA server. In this case, lookup.ld4l.org is an implementation of the QA server. We are indicating that we want to do a search. We're going to do the search on the null authority, and the query that we are making is for eggs. In this particular case, I'm passing in an additional parameter saying I only want to receive 4 matches. You will likely set that parameter to be higher to provide users with a sufficient list of terms from which to choose. In the results, you can see that each result has 3 parts: a URI, an ID, and a label. For some authorities, the URI and ID are the same value as seen here. In others, these may be different values. Our ultimate goal is to select a term and save its URI as the value of the field. So the autocomplete field is set up to show the user the label and use the URI as the value. This allows us to save the URI upon selection and cache the label if desired. I mentioned that you may want to provide additional context to the user to aid in the selection process. Here we see a search of LC genre forms. Each term shows additional context of alternate labels as well as broader and narrower terms. Driving the lookup UI is a call to the QA server API to search LOC genre for a query of animation. The LOC genre authority is configured to return additional context. This example shows the first result, which includes the standard URI, ID, and label fields. It also includes the alternate labels and broader and narrower terms. The goal for the authority-oriented use case is the same. Provide the user with information that allows the user to make a selection of a term and save the URI of the selected term as the value of a single field. The third use case is entity-oriented. In this case, we want to copy an entity, in part or in whole, from an external source into our application. The goal here is to fill multiple fields in our app from a single external entity. The example shown here is the Sinopia editor, which is based on the LC BibFrame editor. The basic workflow for entity orientation is to use the QA search API to find the desired entity in the external source. From the multiple results returned, the user selects a term. Then a second QA API call is made to fetch the details for that term by passing in its URI. We use the fetch results to populate multiple fields. In the Sinopia example, we want to search LC instances for the title, Technological Entanglement, select the instance we want from the results, and then fetch the full LC entity. From the LC entity, we will fill in as many of the fields as possible in the Sinopia form. If needed, we can make additional fetch requests to follow URIs in the LC entity to get even more data. I'm not showing the detailed QA API search and fetch results for this example, as the structure of the results is the same as shown in previous examples. In this episode, we've looked at 3 use cases. In the first use case, we looked at authority-oriented, where the goal was to store the URI of a single term. So we did a search through QA of an authority to find that single term and get its URI. The second use case was the expanded context-oriented, where our goal was to enhance the display of a term. In that case, we just did a fetch through QA to get the additional information we wanted to display about the term. And the third use case was entity-oriented, where our goal was to copy an entity in part or in whole from one system to another. So we did a search for the entity we wanted to copy. Once we selected one, we did a fetch to get as much information about the entity as we could so we could copy it into our own system. I hope these use cases give you a sense of what you can do with the QA server to leverage external authorities in your application. See the comments for more information on how to get started.